Let's talk about types of. Okay, good day everyone. On this episode, I'll be talking about the types of chemical equilibrium. On the previous episode, I talked about equilibrium and the meaning of equilibrium. How does chemical equilibrium means or is said to be also dynamic equilibrium? So, what is the relationship between chemical equilibrium and dynamic equilibrium? Why do we say that dynamic equilibrium is equal to or is the same as chemical equilibrium? As long as there's a forward and backward reaction occurring at the same state, we say it is a dynamic equilibrium. Are you getting it now? So back to the main topic for this episode. We're talking about types of chemical equilibrium. Now, the first type of chemical equilibrium is what we call the homogeneous. Is what we call the homogeneous. Is what we call the homogeneous chemical equilibrium. Now, the homogeneous chemical equilibrium, it's a kind of equilibrium whereby the reactants and the products are in same phase. Now, what am I talking about same phase? Or what do we understand? We already understand what chemical equilibrium is, right? A chemical equilibrium is also a dynamic equilibrium. It's also a dynamic equilibrium because it involves a reversible form, which is the forward reaction and the backward reaction. Do you get it now? So homogeneous, the word homo means one. Homo means one. So, and homo also talks about same. So what is the phase that we are really talking about here? The phase I'm referring to here is the gaseous phase. We have what we call the gaseous phase. We have the liquid phase, or what we call the aqueous phase. Then finally we have what we call the solid phase. So as long as the reactants and the products are in let's say everything we have is gaseous plus gaseous is giving us gaseous phase, right? Then this means that it is homogeneous. Liquid plus liquid or aqueous plus aqueous phase will give us aqueous reactants plus another aqueous reactant will give us aqueous product. Then it is homogeneous. It is what we call homogeneous chemical equilibrium. The gaseous phase plus gaseous phase giving us gaseous products. It's also known to be what? Homogeneous. I get it now. So let's take a look at an example. Let's take a look at one example here. For example, we have homogeneous at the same time. Let's take this thing. Homogeneous phase can be in two forms, or homogeneous chemical equilibrium can be in two forms. Homogeneous chemical equilibrium can be in two forms. Now, the first form of homogeneous chemical equilibrium is the state whereby the number of molecules of products is equal to the number of molecules of reactants. Now, at this state now, we have two forms of homogeneous. Forms of homogeneous chemical equilibrium. Forms. The first form is when the number of molecules of product is equal to the number of molecules of reactants. Now, let me give one example here at this state. Now at this state here now, we have for example N2 plus O2 is giving us forward and the backward reaction of NO. Now what I want you to understand in this reaction here is that this phase is a gaseous phase, this phase is also a gaseous phase, and this phase is also a gaseous phase, and we have one molecule of nitrogen gas. It is first of all, you understand that it's homogeneous because everything is gas, right? That's why we call it homogeneous. Then what form? Is it the first form? Is it the form A of homogeneous or form B? But for example of this form A is that this molecule here of nitrogen gas is carrying 1. Are you getting it now? It's carrying 1. Okay, let me just write the balanced equation. This is the balanced equation here. This is the balanced equation. Now, this is telling us that this particular nitrogen gas is carrying 1 molecule of nitrogen. Then this is also carrying 1 molecule of oxygen. Then it is now giving us 2 molecules of nitrogen gas and oxygen gas. Now this is a balanced chemical reaction because we have this is a balanced, or this is a chemical equilibrium whereby the number of products, this is products, and this is our reactants, or these are our reactants. Now we have one molecule of nitrogen gas plus 1 molecule of oxygen gas. Now the 2 is giving us 1 plus 1 is now giving us what we call 1 plus 1 is now giving us 2 molecules of the NO, the nitrogen oxide. So what we are trying to deduce in this first form of homogeneous chemical equilibrium is that the one reactant plus the other one reactant gave us 2 molecules of our product. Are you getting it? 1 molecule of our reactant plus 1 molecule of our reactant gave us 2 molecules of our product, and this is correct because, or this accepts or correlates with what we call the first form of homogeneous reaction. This correlates with the first form of homogeneous reaction. So let's take a look at another example here. Let's take a look at the second form. Now okay, let's take a look at another example. We have H2 plus iodine 2. Then we have a forward and a backward reaction. Then we have 2HI. Yeah, then we have 2HI. Now what you should understand here is that hydrogen is a gas, is in the gaseous phase, and this one is also in the gaseous phase. This is also going to be in the gaseous phase because it is an homogeneous chemical equilibrium. So they are in the same phase. Now here we have 1 molecule of hydrogen giving us 1 molecule, adding with 1 molecule of iodine is giving us 2 molecules of hydrogen iodide. I get my point now, giving us 2 molecules of hydrogen iodide. So 1 plus 1 is now giving us what we call 2. So this is the other form of this is the first form of homogeneous reaction. This is example 1, this is example 2. Now the two of them are telling us that the number of molecules of products is equal to the number of molecules of reactants. Are you getting it now? So that is this is the first form of homogeneous reaction, homogeneous chemical equilibrium. This is the first form of homogeneous chemical equilibrium. So let's take a look at the second form. Let's take a look at the second form of homogeneous chemical equilibrium. Now the second form of homogeneous chemical equilibrium, it is that form where the number of molecules of products is not equals to the number of molecules of product is not equals to the number of molecules is not equal to the number of molecules of reactants. And this one is just basically is the second form, right, of homogeneous chemical equilibrium. Is the second form of. Now let's take a look at one example here. We have SO2 plus O2, and it's giving us a forward and a backward reaction of SO. It's giving us SO3. Now what you should understand here is that, okay, we're having 2 here in the question before I explain it. Now it is homogeneous because we have gas, and because the phase, because the phase, this is the phase I'm talking about, phase, because the phase is gaseous. Now if you look at this, these are our reactants, and this is our products. Now if you look at the molecules here, we have two molecules of SO2 plus 1 molecule of oxygen. It's supposed to give us 3, right? But it is not giving us, but the balanced equation here is not giving us 2 molecules of SO3. Now this is 2 plus 1. It's supposed to give us 3, but it is not giving us 3. It is not giving us 2. So this is not equal. This is our products, this is our reactants. So this is the second form of homogeneous chemical equilibrium, where the product is not equals to the what? The product is not equals to the reactant. So that is the first explanation on what we call homogeneous chemical equilibrium. We have 2 forms. This is the first form, and this is the second form explained earlier. So to round this up, I will be explaining what we call the second type of chemical equilibrium. This second type of chemical equilibrium is what we call this is what we call the heterogeneous chemical equilibrium. Now heterogeneous chemical equilibrium is just simply don't forget, the homogeneous chemical equilibrium is when the reactant and product are in same phase. But for heterogeneous chemical equilibrium, the reactants and products are in different phases. Now let's just take 2 examples on this. Now the first example on this is that we have CaCO3, and because it is a chemical equilibrium, it means it is a reversible equilibrium. It means it can go forward and it can go backward. Then we have a we have the products as calcium oxide plus carbon dioxide, right? Carbon dioxide. So now this is in the solid state. Calculator is a solid state. Calcium oxide is also a solid state or solid phase. Then this carbon dioxide is gaseous phase. Now this is the different phases. This phase, and this phase. This is an example of heterogeneous. Okay, let's take a look at another one again, which we have let's take a look at another example whereby, let's say we have 2Na NaHCO3 is giving us a forward and backward reaction of 2CO3 plus CO2 plus H2O. Now look at it now. Now this is a solid compound. This compound is in a solid state. This is also in a solid state. This is in a gaseous state, and this is in a gaseous state. So can you see that all the entities here, the reactants and the products, are in different phases. They are not in similar phases. We have gas, solid. Solid is giving us solid, gas. Solid is giving us solid, gas. Are you getting it now? So they are in different phases. So this is what we call heterogeneous chemical equilibrium. The reactants and the product are in different phases. So the difference between heterogeneous and chemical is just their phases. Just their phases. So do well to follow the next episode. There I'll be talking about equilibrium constant. In the next episode. So do well to like this video, at the same time share and repost, and make comments of any form of question you have. Thank you.